Hello, we are CSAW Team B, and this is our presentation for the final competition. I am Akshat Sissa.
I'm Parker Harris.
And I'm Kevin Park.
Lisa, our captain, was unable to be here today. So for us, when we were using our softwares, the main softwares we used were Ghidra and Docker. We used those Ghidra specifically to compile the binary code into readable code and also be able to see the assembly code. Docker was very much a container to store our softwares and any other files or anything that we thought would be useful to use as a group. We attempted to use VirtualBox for their virtual machine, and we attempted to use Anger, but we ran into some problems and we didn't feel that they were useful, very useful when we were solving different solutions.
While in the process of setting up Docker for the RISC-V environment, one thing I have realized that the precompiled RISC-V toolchain that is available on the link toolchains.bootlin.com, which is recommended by one of the RISC-V documentation, has a very outdated toolchain, and it lacks one of the key components, which is GDB. And trying to compile that toolchain ourselves at the Docker build step can take about up to an hour, which is more than anyone is willing to spend in the Docker setup or any sort of setting up process. So although this is not a big of a contribution, I have added GitHub Action to the official GitHub repository, toolchain repository, which compiles and packages the toolchain binaries in several few different environments, and then publishes them as artifacts. And yeah, and you can check that out in the GitHub PR in the link before, and it has been merged into the repository. Can you?
So one of the hex files that we solved was called sequence.hex. This binary works by splitting the input by space into two separate inputs. On boot, there is a Fibonacci-like sequence that is generated, and the solution to this hex file is two specific indexes of the sequence as the passphrases. So all we had to do to solve this one was to put a breakpoint in GDB and check what values of the sequence they're comparing against, first one and then the second one, and then rerun it and input the correct sequences. For burst.hex, this is a hex file that takes in three different integers in the way of having a space between each number of the integers. So the first 7 goes to the first variable, ivar0 or ivar1, and then the next 4 goes to ivar2, and then the last 7 go to ivar3. None of these can be 0, but the solution can be boiled down to a system of equations to find the correct answer and be able to return 1 as a successful password.
Another challenge we looked at is Amnesia. This challenge is a little unique in that it does not compare the user input right away with the solution and check for solution, but rather it takes the current user input, checks if it's longer than 7 characters, but then it also checks for the solution against the previous input that is saved in the flash memory. Then it takes the current input and saves into the flash memory. So therefore, you have to input the solution twice in order for you to get the output whether your input was correct or not. And I think that's where the Amnesia name comes from. And looking at the quick decompile source code on the right, where it calls Amnesia check, that comes before it compares against the length of a character and doing anything with the current new input. And also the solution checking process involves taking the user input and then from a specific character, it checks against other specific characters within the input at the certain specified location. Therefore, there are infinitely many possible solutions, and since it also has like iterative loops to go through multiple characters, I thought it was best for us to just come up with the solution pattern generator, just write one, and then define the predefined condition to generate one of the working pattern, which is listed in, which is shown in the below with a bunch of hex characters and with some other characters that the binary checks against. And that is our presentation. Thank you for tuning in.